Section 5.2, Sum and Difference Formulas, Part 4 of the notes. Example 8, we're going to find sine of alpha plus beta. We know that cosine of alpha is 8 over 17, and it lies in quadrant 4. We know that sine of beta is -1/2, and beta lies in quadrant 3. So what we need to find is cosine of beta and sine of alpha. So we're going to do that by drawing our two triangles that are described here and finding the two trig functions that we need. Once we have sine of alpha and cosine of beta, we'll be able to find sine of alpha plus beta. So first of all, I'm going to draw my triangle for alpha. I know that cosine of alpha is 8 over 17, so I've labeled my adjacent side and my hypotenuse side. For beta, I know that sine is -1, which is my opposite, and over 2, which is my hypotenuse. Back to my alpha triangle, I'm going to solve for the other side, solve for x here. And we get x equals 15. I'm going to write it as a -15 because I'm in quadrant 4, and my y coordinate there should be a negative. Now to solve for the unknown side on my beta triangle, this is my x coordinate of the triangle since it's on the x-axis, and since I'm in quadrant 3, I know that it's going to need to be a -√3. So now we know cosine of alpha, we know sine of beta. We also know cosine of beta because if I look at my beta triangle, my adjacent is -√3 and my hypotenuse is 2. We know sine of alpha by looking at our alpha triangle is -15 over 17. Now that I have those 4 values for those trig functions, I can find sine of alpha plus beta. And that's going to be my final answer. Example 9, find tangent of alpha plus beta. So this time we're given sine of alpha is equal to 5 over 6, and it's in quadrant 2. Remember, pi over 2 to pi would be quadrant 2. And I also know that tangent of beta is equal to 3 over 7, and that is in quadrant 3. So looking at our sum formula for tangent, we need to know tangent of alpha and tangent of beta. I already have tangent of beta, so I don't really need to draw a triangle for beta at all. I just need to focus on alpha and draw my triangle in quadrant 2 and figure out what tangent of alpha is. So here's my triangle for alpha. I've labeled the opposite side as 5 and the hypotenuse is 6, and I need to find my adjacent side now. Since we're in quadrant 2, I have a negative x coordinate here, so it's going to be -√11. So I know that tangent of alpha is 5 over -√11, and I know tangent of beta is 3 over 7. So I'm ready to use my sum formula for tangent. I'm going to plug in what I know for tangent of alpha and tangent of beta. I can simplify the bottom by multiplying those two fractions together. Now, if you are not going on to calculus next year, this answer is acceptable and I will take it just like it is. It's kind of ugly, don't get me wrong, but we'll take it with this answer. If you are going on to calculus next year, then you need to work on rationalizing this, which I'm going to do on the next slide. So again, you only need to watch this part right here of the video if you are someone who plans to go on to calculus in the future and need to know how to rationalize. So I'm going to start here by making common denominators on the top and common denominators on the bottom. They happen to be the same denominator on the top and the bottom. Now I'm going to combine the top two fractions and combine the bottom two fractions. And then I'm going to keep flip change. So keep the numerator the same, flip the denominator, and change to multiply. We can cancel out the 7 square root 11 on top and bottom. And now we're going to rationalize by multiplying the top and the bottom by our conjugate, which is 7 square root 11 minus 15. At this point, you're going to FOIL or box method. I did that off to the side because I didn't have much room here. Simplify your denominator. And then I can divide a factor of 2 out of each of those terms. Example 10. If cosecant of theta equals negative 17 over 8 and theta is in quadrant 4, find sine of pi over 4 plus theta. So if we're going to find sine of pi over 4 plus theta, if we look back to our sum formula for sine, we have our sine of u value and our cosine of u value because we know that u is pi over 4. So we can find sine of pi over 4 and cosine of pi over 4. But we need to figure out what cosine of theta is and what sine of theta is. So we're going to draw a triangle with the information we were given to find those two values. So we're in quadrant 4, so here's my triangle. There's theta. And I know that cosecant is just sine flipped, so that's going to be hypotenuse over opposite. Our hypotenuse is always positive, so that's going to be 17. And since we're in quadrant 4, our y-coordinate is going to be negative, so negative 8. We're going to find the third side. That's going to be positive 15 because our x-coordinate would be positive in the fourth quadrant. So now we need to figure out what sine and cosine of theta are. Sine is opposite over hypotenuse, so negative 8 over 17, and cosine is going to be 15 over 17. Now that we have that information, we can use our sum formula for sine. I'm going to plug my values in for sine of pi over 4, cosine of theta, cosine of pi over 4, and sine of theta. Remember, we get those sine and cosine values for pi over 4 by thinking back to the unit circle and finding the x and y coordinates at pi over 4. Now I'm going to combine fractions by multiplying my numerators and denominators, and then write it as one fraction. 15 square root 2 minus 8 square root 2 is just 7 square root 2. And then we still have 34 on the bottom.